Good evening, sir. I am Jiaming Lin. Student ID MAT2109469. This video, I'm going to give a presentation of the Project B, which is cubic spline with parabolic runout. Let's look at the textbook. From the table of the textbook, we can know the form of parabolic runout spline. So now we can start our Python code. First of all, I import NumPy and Matplotlib. This step gives my code the ability to compute matrices and draw 2D diagram. Next step, I design a user interface, a guidance to help user use this program. I let the program print, please enter the abscissa values of the 6 points, separated by spaces. Please enter the ordinate values of the 6 points, separated by spaces. To guide len, enter the 6 coordinate point with the number of intervals n equals to 5. And next, I define the interval h. Since x coordinates are equally spaced, so we just define h equals x1 minus x0. Then I define the matrix h and the matrix y, just like the textbook showed, this one and this one. Also from the textbook, we know h multiply m equals to y. Here, m is the quadratic differential value. So to calculate the values of m, I use this code to transform the row vectors of y into column vectors. Then I use this code to calculate y multiply the inverse of h to get values of m. After we found m, we can start to calculate the spline curve coefficients. We know the equations are like this. But to make programming easier, I rewrite equations from the textbook and change it to ascending power arrangement, just like this. And here, A is the constant term, B is the coefficient of primary term, C is the coefficient of the quadratic term, and D is the coefficient of cubic term. Also from this picture, we can know the method of calculate A, B, C, and D, so I changed them into Python code, and like this. So we get the values of A, B, C, and D. Next step, to let user read easier, I use this code to rearrange them into formulas. Also, to let user easier observe the equation, I use this code to plot the cubic spline interpolation. Above is my introduction of my Python code. Let's see how the program works in real. We open the program, wait for the guideline, and we typed 6 points randomly. And then we can get the equations of 5 intervals and the graph. My presentation is over. Thank you for listening.